Okay, so this video is about working with percentages in science, and there are four main things you need to do, the first of which is being able to calculate the percentage of something. And what I mean by that is in this example here. So looking at this table, which is about energy generated from different sources in 2 different years, the question we're trying to answer is what was the percentage of energy generated from fossil fuels, so that's coal, oil and gas, in 2008. So we're using the 2008 column here and looking to see what the percentage of the fossil fuels is as a percentage of the total. So the formula we need here is the amount we're interested in, so the amount from the fossil fuels, divided by the total amount, so everything in this column, times 100%. You have to remember that formula. It's not on the formula sheet like the other formulae that you might need, so you need to be able to do this from memory. So let's see how that works here. We take the coal, the oil and the gas, we add the numbers up, so 14.2, 2.3, 1.4 to get 17.9 gigawatt hours. Just a little note here, when you're working with units for percentages, it doesn't really matter what the units are, provided you make sure the 2 quantities you're putting in the top and bottom of this division have the same units. If they've got the same units, you'll be fine. Okay? So there's our energy from fossil fuels, so that's the amount we're interested in, which goes on the top. And then we need to work out the total energy, so add up every number in this column to give us 22.4 gigawatt hours, and that's the number that goes on the bottom. So when we do that, there's our percentage, and we get 79.9%. Okay? So whenever you're calculating a percentage of something, it's useful to remember that you should always get 100% or less. You can't have more than 100% of something. Okay? So that's a good check to make sure you haven't done anything silly like put the numbers the wrong way up. Okay, if you're doing percentage of, it should be less than 100% or equal to 100% if it's the whole thing. So the next 2 things that you need to be able to do, which is percentage increase and percentage decrease, kind of go together. So same table again, this time we're interested in how much the energy generated from renewables has changed. So what was the percentage increase in the energy generated from renewables from 2008 to 2012. So we're looking at this increase from 1.1 to 3. What's that as a percentage? Well, you use the same formula for increase and decrease, this percentage change formula, and it's just the change divided by the starting value times 100%. So we need to work out the change from 2008 to 2012, and that's the difference between the 2 numbers. So from 3 to 1.1, we get 1.9 gigawatt hours of change. And then you just put that into the formula with the starting value, the 1.1, because that's the first one in 2008, on the bottom. So when we do that, we get 1.9 over 1.1, which is 100 times 100%, which is 172.2% increase. And you'll immediately notice that we've got here a number that's bigger than 100%, but that's okay. When you calculate a percentage increase, you can get answers over 100%. If this renewables number doubles or more, then you will get an answer over 100%. So it's clearly more than doubled here, because that would be to 2.2. So we're expecting an answer above 100%. So with percentage increase, it's fine if you get an answer that's over 100%. You won't necessarily get one like that, but you might do. Okay? So percentage decrease works in a very similar way. Same formula, except we're looking at a number that's decreasing this time. So the coal, for example, here goes down from 14.2 to 13.7. Again, we do the same thing. The change is 0.5. The starting value this time is our 14.2. We put it in, we've now got a 3.5% decrease. Here again, you shouldn't get a number over 100%, because if you think about what's going on, if you start with a certain amount, say 14.2, then in most cases the energy generated, I mean, you can't reduce that by more than 14.2, and that would be a 100% decrease. The only time that doesn't work is if the number can go negative, but that's quite a rare thing for quantities in science, so that you'll be working with at least. So alarm bell should ring if your percentage decrease goes over 100%. You might have done something funny there, again, like get the numbers the wrong way up in the fraction. Okay, and the last thing you need to be able to do is to work out an amount from a percentage. So this is like the first example, but backwards. So the question you might get here is, let's say we've moved on from our original table now, and in 2014 we've been told that the total energy generated by this situation was 24.8 gigawatt hours, and we're also told that 5.2% of this came from nuclear sources. The question now is, what's the amount generated by nuclear power? Well, you can rearrange the original formula to get this formula now, which is that the amount generated is going to be percentage divided by 100 times the total. So again, we just make sure we put the numbers in the right place, and if we do that for this example, right, what it's really asking is what is 5.2% of 24.8 gigawatt hours, because that's what we're doing. We're taking 5.2% of it from nuclear sources. So how much is that? And put the numbers through the formula. 5.2 over 100 times the 24.8 gives us 1.29 gigawatt hours generated from nuclear sources. So that's what you need to be able to do with percentages. Check back through the video if you missed anything, and hopefully that will really help you.